Okay, so the recording has started. So before we begin, do you have any queries from the last session?
Yes, I was going through the material, this STLC and what is that, STLC in
Yeah.
software testing life cycle. I did not
Mhm.
understand one step. What is the environment setup?
Okay, okay. What is environment setup? That is a great question. So basically, whenever we need to execute our test cases, right? So at that time, we will need a test environment. So the test environment is basically all the details where the testing will be done. So suppose you are working on an web application. So the web application will be hosted somewhere, right? You won't host the application on your local system. So you will mimic maybe a VM or a server where your application will be hosted, and then you will test that application. Now, to do the environment setup, now to host the application, you might need some other applications installed on that system. You might need some test data as well, right, to perform your testing, right? So these things comes under the test data, the environment setup. So
Okay.
basically it's the test environment which you need to set up. If you need to set up the build, if you need to install some of the applications before you begin your testing, if you need to set up your test data, so those things are done in the phase which is called environment setup.
Okay. Thank you.
Anything else?
No.
Okay, so everything was fine, right, regarding the priority and the severity and
Yes,
different
yes.
type of priority severity, like different combinations of them.
Uh-huh.
Okay, okay, great. So what I have done is I have added one assignment today. Okay, so after today's class, you can go through that assignment. I have already uploaded that from my dashboard, so it might be visible to you already. So you can download that assignment and just complete that and upload that, so that I can go through it once, and I can be sure that everything that we have gone through till now, it's clear to you. It's very basic and simple things that I have put there, just to make sure that you are understanding everything,
Mhm.
and you don't need to write. Uh, you can keep it very simple and very brief. You don't need to write the long answers there. It's just to check that you're getting your basics clear.
Mhm.
Okay. So let's start with today's session then. I will just share my screen. Okay. And I hope my screen is visible to you.
Yes.
Okay, great. So what did we learn yesterday? We learned what is bug, what is fault, and what is error. We learned
Mhm.
when, in which phases do we call them as a bug or as an error or as a failure.
Mhm.
After that, we saw how or why the bugs are introduced in a software.
Mhm.
um, then what did we learn? We learned about the priority and
Yes.
severity.
Very. Uh-huh.
Yes. Then we understood the software development life cycle. There were different phases in a software development life cycle. And
Mhm.
then we learned about the software testing life cycle, right?
Mhm.
Which is a part and parcel of the software development life cycle itself. So software testing life cycle comes along with the software development life cycle. Okay, so we will continue learning, because we were discussing that there are different models of software development life cycle, right? So we will try to explore that today. So let's take a look at the agenda that we have today. So we are going to learn about different models. So the first one is the waterfall model. We are going to look at the waterfall model. What is waterfall model? What are the advantages of waterfall model? What are the disadvantages of waterfall model? And when we can use the waterfall model. And then we will look at the V model, advantages of V model, disadvantages of V model, when we can use V model, then iterative model and incremental model. So these are the different type of models which are used in a software development life cycle. Okay, and as we go through, we'll be able to learn to distinguish between them. What are the differences between these different models? So it's almost it will be a theoretical class. There is not much practical things you will be getting to know today. The most important thing is you should be able to distinguish between the working of this model. So from the interview perspective, if I talk about the interview perspective, because once you are in a project, right, once you are in a company and once you are in a project, so that they have a defined set of model that they will be working on. They will be working on a waterfall model, or they will be continuously working on the V model, which is not used in most of the cases, but yes, theoretically it's present. Then either you will be working on iterative model, or you will be working on incremental model. So at that time you don't have to think about what is done in the other model and all. So that is not required when you work on a practical project. So this is just required in from the interview perspective. They might ask you to first explain what is iterative model, and then they might ask you that what is the difference between an iterative model and an incremental model. So this is just required from the mostly required from the interview perspective. And based on that, you just need to understand the basics, how these are different from each other. So that would be enough, I guess, right?
Mhm.
Okay, so let's start with the waterfall model. So this is one of the oldest software development model that the software industry is working on. And this is what from the ancient time, like the software development life cycle has been following this model. Recently, from last 8 to 10 years, there have been changed, and a lot of new software development lifecycle models have been introduced. But this is the oldest model. So this is an example of sequential model, and in this model, the software development activity is divided into different phases. So whatever models we are going to see, those are based on the software development lifecycle model itself. Those are not out of the software development lifecycle. So all the phases that we had in our software development lifecycle, those will be present here. Now it will be arranged according to the working feature of that particular model, right? So what are
Mhm.
the phases in the software development lifecycle? Do you recall those? Or
Yeah,
yeah,
the requirement analysis, then the
yeah.
design, implementation, testing, and I think the last one is deployment and maintenance.
Absolutely. So you can see that these are the same phases which we had in our software development life cycle, right?
Mhm.
And when we talk about software development life cycle, by default, the waterfall model is considered, right? So you don't see anything else there. The structure is also same. And in the software development life cycle model, we already had shown it in a sequential way itself. So here also it's shown in the sequential way. The thing is that you need to remember that in this model, in the waterfall model, what is done is every phase is totally dependent on the previous stage, right? So the design can't be started once the until the analysis is already done and completed. The
Mhm.
implementation can't be done until the design phase is completed. The testing phase won't be started until the complete implementation phase is completed. Okay, until the complete implementation phase is completed. In the same way, deployment will be done once the whole testing is done and you have stopped your testing, then only the deployment will be done. And once the product is deployed, then its maintenance activity will go on, right?
Yeah.
So the thing that we need to understand and remember here is in waterfall model, every phase is totally dependent on the other phase, on the previous phase. And once a phase is completed, wholly completed, then only the next phase will get started. So you can
Mhm.
see the last two line that it is divided into phases, which we already know from our software development life cycle, that is already divided into certain phases, and output of one phase becomes input of the next phase. Whatever we understand from the requirement analysis, that is sent, that is used for the designing phase. Whatever is the output from the designing phase, that is used in the implementation phase. From the implementation phase, whatever we are getting, what we get normally, what is the output of the implementation phase? What do you think?
You're ready to test the product at that time.
Yes, so the build is the output, right? From the
Uh-huh.
implementation phase, once the developers has developed, completed the whole development of the application. This thing we need to remember. Like here in the waterfall model, what is done is, if they're into implementation phase, then the output will be the whole application, right?
Mhm.
And then
Mhm.
the testing team will be getting the whole application as a input for the testing phase, and they will start testing on them. Now once the whole testing is done, what will be the output? The output will be test reports and the metrics, the bug reports. So this will be the output, and based on that, the confidence or the quality will be measured, and based on that, the deployment will be done. And once the deployment is done, the users are going to use it, it will be in production, and based on the bugs that are coming or the patches that are required, based on that, the maintenance will be done.
What do you mean by maintenance? I mean, like
So the
maintenance.
maintenance is basically once you have a software running, right? You use different applications on your system, we use different softwares, and so that means that software is in production. Whenever we are using it, that means that is in production. So now in the production phase, what could happen is, the first thing is we can get some bugs there when it is in production. So if the software is in production and we are getting the production bugs, so that has to be fixed by the development team, right?
Mhm.
So that is the maintenance activity.
Oh,
Now the next thing, you need to give some updates or patches in the software as well, right? So those comes under the maintenance activity.
so is it tested again at that point?
Yes, it has to be tested. So in the maintenance phase, you can say that it's again like the implementation of the changes. Then again it will be tested. Then again it will be deployed. So from the maintenance phase, if you are in the maintenance phase and if there has to be any changes in the software, then again it will go to the implementation, testing, deployment.
Mm.
Okay. So the next line says is that it is mandatory for a phase to be completed before the next phase starts. In short, there is no overlapping in waterfall model. There is no overlapping of the phases in waterfall model. Okay.
Mhm.
So these are the different phases, and I guess we already know about this. What is done in the analysis phase? So in the analysis phase, we actually get the requirement as a document from the customer. Then we do the feasibility analysis of the requirement, and we try to understand the requirement from our side, right? Then in the design phase, so in the design phase, it's mainly the developers do their designing of the software. The architecture is defined, the interface representation, what will be the interface representation, what will be the algorithmic details. So those things are done in the design phase. So once these things are finalized, then it will come to the implementation, where the developers will write their code. They will use the database, they will use the documentation and all. After that, it will come to the testing phase, where we will test that all the modules are working together. So the integration of the different modules will be tested here, and as a whole, the system will be tested as per the specification. After that, once the testing is done, then the code will be deployed, the product will be deployed, and then the user will be trained on how to use that application. And finally, the maintenance will be done, as we talked about, the bug fixes, the added functionality. So these things will be done in the maintenance phase. Okay. Okay, so let's look at some of the advantages of disadvantages of waterfall model. Now, this is also a very important question from the interview perspective. They might ask you that what is in a waterfall model, and what do you think? What are the advantages of or the disadvantages of the waterfall model? So you need to at least remember two advantages, or you don't need to remember it as well. Like, if you understand what is waterfall model, you will be able to derive what are the advantages of it or what are the disadvantages of it. And same goes for the other models as well. I mean, you don't need to theoretically remember that, okay, these were the points that were mentioned, and I need to remember these were the advantages or these were the disadvantages. No, if you understand the basic structure of the model, if you can remember the diagram, how the diagram shows and how does it behave, you can easily derive what are the advantages of it and what are the disadvantages of it. So what are the advantages of it? So each phase of the waterfall model has some specific deliverables, right? As we were talking that uh, the output of each phase becomes the input to the next phase. So each phase has its specific deliverables and a review process. Then phases are processed and completed one at a time, right? So as there is no overlapping of the phases, so phases are processed and completed one at a time. Now it works well for smaller projects where requirements are very well understood. So if your requirements are well understood and requirements are not changing, so that thing also you need to keep in your mind, that the requirement for using the waterfall model, the requirement has to be fixed, and those requirements should not be changing. Because what will happen if the requirements are changing in nature? Because here, like in waterfall model, there is no overlap in between the phases, right? So if you have got uh, a requirement from the user or from the customer, and you have started working on it, so what happens in the waterfall model is, in the requirement phase, the analysis will be done, in the requirement analysis will be done, and whatever the the documentations you are generating from that, that will go into the design phase. Now there is no way that you can go back to the analysis phase in waterfall model. Okay,
Mhm.
so this is the thing that you need to understand, that there is no way, once you are into testing, you can't go back into the implementation phase or into the design phase. So this is something that is a shortcoming of waterfall model.
Mhm.
The maintenance activity is different. Once you are in the maintenance activity, then if you are getting some bug or you need to do some updates, then you can go back to the implementation phase. So until you are into the maintenance phase, you can't go back to the previous stages or previous phases.
Mhm.
So that's why whatever we are doing in a certain phase, that has to be fixed. I mean, once the design stage is fixed and we are into the next phase, which is implementation phase, so at that time we can't go back and say, okay, we need to do some changes in our design, we need to do some changes in our architecture. So waterfall model doesn't allow it. So it will tell you that, okay, if you need any changes, let whatever we have fixed, let us complete that, let us go ahead and do it, and then we'll come back and do the changes once this version is released totally. So that is done in the waterfall model. So that's why whatever we are doing in a particular phase of waterfall model, so that has to be fixed. We can't change it in future. And it reinforces the notions of define before design and design before code, because as we are already discussing, because whatever we are doing in a certain phase, that has to be fixed. So before we start designing the architecture and the internal structure of the software, we must need to define it before. And before we start coding, we need to design it before. So these are the advantages of some of the advantages of waterfall model. Let's now see what are the disadvantages of waterfall model, because this was the oldest model. Now if the latter or the other models has evolved, so there must be some of the disadvantages of this model which has forced some other models to be evolved, right? Okay, so let's see what are the disadvantages of waterfall model. So the first one is delivery of the final product is late, as there is no prototype which is demonstrated immediately. So this will be able to understand once we have gone through the all the other models, right? So just try to understand what does this model say. So this model says that until and unless all the phases are complete, right, we don't have anything to provide demo to the customer. We don't have any prototype to demo to the customer. So in other phases, what we do is we start small. We build a prototype of the software, we demo it to the customer, and if the customer is happy with that, we start implementing it wholly, right? So that is followed in some of the models, but that is not done in waterfall model. So at the what is done in the waterfall model is basically, once everything is done, once the requirement is fixed, once it's designed, once is the whole application is developed, it's tested, and then we give it to the customer and we show it to them. So in between the development, in between the testing, there is no intervention from the customer side. They are not able to see anything about the software or the application that is being developed, right? So what happens is, at the end, if you're showing it to the customer and now the customer is saying, okay, so you have developed this, but I think I was not talking about this thing, I actually needed this actually. So at that time, like, everything is developed, right? Everything is developed, everything is tested, and now if the customer is coming with like, no, this is not actually what I wanted, so at that time it becomes costly, and it becomes, the overall it extends the overall project timeline more to do some changes. So that's why it says that delivery of the final product is late, as there is no prototype which is demonstrated immediately, right?
Mhm.
Okay. So what does the next point says? It becomes very difficult to move back to the phase, which I already told you. For example, if the application has now moved to testing stage and there is a change in requirement, it becomes difficult to go back and change it. So that is certainly, that is the case in case of waterfall model. We can't go back to a previous phase and we can't make the changes there. It has to be, the whole life cycle has to be completed first, and then only we can go back to a previous phase and do the changes from there. So that is one other disadvantage of waterfall model. Now the next one is, it's good for, as we are talking, it works well with the smaller projects where the requirements are very well understood. But if the requirements are changing in nature, or the requirement or the project is very long and ongoing project, where you are getting new requirements, where you are getting new designs every day, or like there are two type of projects. Let's talk about something that is very much practical. So there are two types of project. When you'll start working, you'll get to see that there will be some projects which are, you know which have started almost 10 to 15 years back, and it's still going. And until the company is there, until they are doing their business, the project will remain. So in this kind of projects, if you are following the waterfall model, so it becomes very difficult, because they are always coming up with some of the requirement changes. They are always coming up with the feature changes. And when you are working in a waterfall model, it's not easy to incorporate those changes. And also, like, whenever you are showing it to the customer, it's already everything is done, and then you are demoing it to the customer. And then if the customer says that no, I need these changes, you need to go back and do everything again. So that's why it's very hard if we follow the waterfall model for long and ongoing projects where the requirements are changed frequently. Now, if the requirement is fixed and it's a short term project, then you can go ahead with the waterfall model, because you know that the requirement is not going to change. And the the architecture is fixed. It's not going to change over time. And the everything is fixed there. So in that case, you can follow the waterfall model, and you can do it sequentially. All the phases are sequential in waterfall model. And finally, since the testing is done at later stage, it doesn't allow identifying the challenges and risks in the earlier phase. So the risk mitigation strategy is difficult to prepare, because here what we see, what we understood is, uh, once in the designing phase, and then we come to the what was that, the implementation phase. So in the implementation phase, the whole product is developed at once, right? And then the testing of the whole, like, different modules and wholly as a system, the testing is done. So what's the issue here is, if there is bugs or errors in the earlier stage of the development, so those are not caught in the earlier stage. And now, once the whole application is ready for testing, then only you are testing it, and you start getting those bugs. And now, if those are, I mean, blocker bugs, if those are blocker in nature, in this case, your testing will be halted until those bugs are fixed from the development side. So that is one more disadvantage of waterfall model, because the testing is done at a very later stage, and at that time, if you get the blocker issues or something like that, so it is a challenge for the whole team. Like, the development team, once the development team again fixes those, then only we'll be able to start the whole testing of the application. So these are some of the disadvantages of the waterfall model.
Mhm.
Okay. So any queries till now? Anything
No,
that you have doubt on?
no.
Okay. So when to use waterfall model? So we have already got an idea that when we should go for waterfall model. So every software developed is different and requires a suitable STLC approach to be followed based on the internal and external factors. I mean, there are different software development lifecycle models as we are already talking about. So we need to first look at the, so every model has its own advantages and disadvantages over other modules or over other models, right? So first you need to see that what is the thing that I am going to develop, what is my project, what is my product, and based on that I need to choose a model, right? So if my requirements are well documented, those are clear, those are fixed, if my product definition is stable, product definition means it's same, the requirements, what you are going to develop, what will your product look like. So if those are fixed, those are well documented, and those are clear, those are stable, so at that time you can go ahead with the waterfall model, because there won't be any intermediary change, right? And that helps you. So if your requirement is fixed, then it helps the developers to fix their design, and then it helps the testers as well to develop their test planning, develop their test cases. So everything goes smoothly in that case if your requirement is fixed. So if the requirements are documented, clean, fixed, and stable, then you can go ahead with the waterfall model. If the technology is understood and is not dynamic, if your technology is so where does in which phase do you think this thing is required? Technology is understood and is not dynamic.
And the requirement, I didn't understand your question.
So basically what I'm trying to understand is in which phase this technology part comes up. Technology is understood and is not dynamic. So in which phase it's talking about, in which phase of the waterfall model this
This is
is
the
required?
design.
Yes, absolutely. In the design phase, we will need the technology, right? We need to fix that. What are the different language that we are going to use? What will be the architecture? So at that time, this technology part will uh, be in the picture. So now if the technology is understood and it's not dynamic, then you can fix a specific design for that product or that application or the software. But if your technology is dynamic in nature, in that case your architecture or the architecture of the software will be changing, that will be dynamic as well. Now your if a phase like if the design phase is dynamic in nature, then you won't be able to do the latter phases in a smooth way, right? Because your
Mhm.
design phase will be always changing. So that's why like your technology should be understood and it should be static, it should not be dynamic. Then the next point is there are no ambiguous requirements, so that is understood. There are ample resources with required expertise are available to support the product. So the resources are and the required expertise are available to support the product, and the project is short. We already talked about this, that if the project is of long term and always changing, so at that time it won't be a good idea to use the waterfall model. Okay. So
Mhm.
you don't need to, remember all these points theoretically. It's absolutely not required. You just need to understand what is waterfall model, and if the phases are, happening in that way. So what could be the possible advantages of disadvantages of the waterfall model? So that's all
Mhm.
that is required, from the interview perspective. Later, once you are in a project, so they will be already using a particular model. So at that
Mhm.
time, these things, don't actually matter a lot. These are in generally required from the interview perspective only.
Mhm.
Okay. So any question before we move to the V model?
No, no, no.
Good. Okay, okay. We can start with the V model then. So before we come to the V model, were already talking about the verification and validation yesterday. So do you remember what is the difference between verification and validation?
Yeah, as I understand, verification is something that happens during the development phase,
Mm-hmm.
where we want the expected behavior and the actual behavior to be met. So we do this verification during the development phase, and then validation, I understand, if I'm right, it is in the final phase when you have the end product and we are seeing if it meets all the requirements.
Hmm. So basically, in one sentence, what is verification? Verification is making sure that whatever we are developing it correctly. Okay. And
Mhm,
validation is whatever we have developed it correctly. Is it clear?
yeah.
So verification is in the development phase, whatever we are developing it in a correct way. So verification of that comes under in the development phase. And validation, in the validation section, you already have something, right? So you have already got the output. Now you are validating that whatever has been developed, it has been developed in a right way. There is no deviation in between the expected and the actual.
Mhm,
So that is validation. So I that is also a very important question for interview, so that's why I just asked you. So if the interviewer asks you regarding what is the difference between verification and validation, in a single statement you can say that verification is the making sure that whatever we are developing it correctly. Validation is whatever we have already developed, so that has been developed correctly, so that is validation.
mhm.
Verification happens in the development phase, validation happens in the testing phase. So now what we are going to see is the extension of the verification and validation in the V model. So this is also an extension of the waterfall model, because this is also a sequential model. Okay. Now the V model is an SDLC model. Of course, it's also a software development lifecycle model where execution of process happens in a sequential manner. Here also the processes happens in a sequential manner in a V shape. It is also known as verification and validation model. So in the left side, you are seeing in the design, you can see that all the things are as requirements, right? Business requirement, system requirement, high level design, low level design. So this all comes under the coding phase or like the development phase, right?
Yeah.
And in the right side, what you can see is the testing, the unit testing, the integration testing. We'll talk about these things later. What is unit testing, what is integration testing, what is system testing, what is acceptance testing. But this is for sure, you can understand that these things comes under the validation thing or the testing thing, right? So the left side is the verification, the right side is the validation. So this is also known as the verification and validation model, the V model. So this V model is an extension of the waterfall model. Why? If someone asks you that why we can say that the V model is an extension of the waterfall model, what will be your answer?
Don't know. I don't know.
Okay. So the answer will be this is also a sequential model. Okay. So every phase uh, is placed in a sequential manner. So here also, like, the business requirements are coming first, then the system requirements are coming. So system requirements, high level design, low level design. So this three comes under the design phase itself. Okay.
So what is different?
So the difference is basically when you call it as a system requirement. So system requirement is what is the uh, requirement of your application. So from the business requirement, the system requirement will be derived. So suppose if I call it as a if I take the example of a particular website, so whether that website will be, whether the cloud architecture is required there, okay, uh, which OS, which operating system will actually support that application. So these are the system requirements. Okay. Now when you go to high level design, so high level design, it's actually from the uh, developer's perspective. You just need to understand it. Like high level design is, you are saying that okay, so there will be it will be a three layer architecture. I'm not sure whether you will be understand the three layer architecture. So three
No, I
layer
don't.
yeah, yeah. So it's more from the developer's perspective. So three layer architecture is basically, there will be a front end. I mean, front end means the UI that we get to see. So you can take it as the front end. Okay. Then there will be some middleware, which we call it as APIs. So do you know what is API?
No, no, I'm totally lost with this one.
Yes. Okay. So that's why I don't want to, get into details, because that is not required for you. So basically, there are when we talk about the architecture of a whole software, okay, so at that time, in the design phase, when the developers are doing the design, the architects are doing the design, so there is a step by step approach. First they will define some of the system requirement. I mean, what operating system, just understand this example, what operating system will this application will be supported in, whether it will be supporting in the Windows system, or it will be the Mac system, or it will be the Linux system. And if it's supported only in Windows system, which version of operating system, or which version of Windows, whether it will be supported in Windows 10 and later, or Windows 7 and later. So those comes under the system requirement. Okay.
Yeah, so if I understand it right, is this what I mean? This is how I understand. In the V model, it's similar to the waterfall model, but in every phase, there's some testing happening.
Yes, I was going to come to that later, but before that, I just want to understand how this design phase is divided into these three different phases. Whatever you told, that is correct, that is absolutely correct.
Okay.
Yeah. So this design phase is, then once the system requirements are defined, then we have the high level design. So in the high level design, basically you can say that on a very high level, right, on a very high level, the architecture is defined. And then when we talk about the low level design, then it's I mean, it's on a low level. I mean, each individual model, like we can take the example of the Amazon.com, as we were discussing from the first session, that there are different modules in Amazon.com. Now when we are in the system requirements phase, we talk about on which systems, or on which VM, or on which operating system we can the Amazon.com will be supported. Okay. Whether you will be able to open it on a Chrome browser, or whether you will be able to open it on some other browsers as well. So this comes under the system requirement. Now what will be the high level design? The high level design will be like what will be the different modules. How can we divide the whole Amazon.com into different modules? So that is high level design. Now low level design is what will be the different databases we'll be using in different modules, how those different modules will be communicating in between each other. So that goes into the directly into the coding, or what will be the underlying architecture. So that goes into the low level design. So these are the step by step approaches. Okay. And then the coding will start,
Mhm.
and then the testing will be done. So so then coming to your point, whatever you have said, that each phase has a specific testing associated with that in the V model.
Does it mean that since each phase has a testing associated with it, does it mean the requirements can change at each phase if the client wants to change the requirements?
No, in this phase that is not going to happen. So once the requirement is fixed, then only we'll go to the system requirement, because this is a extension of the
Waterfall.
waterfall model.
Was
And
okay.
one thing you need to remember, that it's also a sequential model.
Okay.
So if it's a sequential model, then you can't go back to the previous phase and you can't make the changes there.
Okay.
Okay.
Yeah.
So this means that for every single phase in the development cycle, there is a directly associated testing phase. Okay.
Mm-hmm.
But it's not like that once you have your business requirements, you will do the acceptance testing. This is not like that. I mean,
Mm-hmm.
don't think it likewise that if it's connected, then whenever the business requirement is fixed, we'll do the acceptance testing. It's not like that. When we'll
Mm-hmm.
do the acceptance testing, we'll keep the business requirements in our mind. When we'll do the system testing, we'll keep system requirements in our mind. When we'll do the integration testing, we'll look at the high level design. And when we'll do the unit testing, we'll keep the low level design in our mind. Okay, so that's why these are connected. But
Mm-hmm.
that doesn't mean that, whenever the business requirement is done, we'll go to the acceptance testing. No. So this is a
What
sequential. Yeah.
mhm. What could be a probable interview question on this V model?
So the probable interview question is, how. So the first question is again, what is verification and validation model, and what is verification, what is validation?
Mm.
So that is the most important question. And then they might ask you that what is the advantage of V model over the waterfall model.
Mm-hmm.
So from the interview perspective, these are the question that you can expect.
Mm.
Okay, so if you understand what is verification and what is validation, that's enough to answer these questions.
Okay.
Yeah.
Yes.
So this is a highly disciplined model, and the next phase starts only after completion of the previous phase. So the only thing is, in the waterfall model, what was there? I mean, this were coming one after another. Here also, if you see this arrow, this is coming one after another. So this is also the
Mm-hmm.
sequential model. The only thing is, each testing phase is tagged with the some of the
Next.
development phase.
Mm-hmm.
Yeah. So you can see the left side of the model is software development lifecycle. This is a software development lifecycle. The right side of the model is software testing lifecycle, because in the software
Mm-hmm.
testing lifecycle, we saw this, right? The unit
Yeah.
testing, integration testing, system
Yeah.
testing, acceptance testing. The entire figures look like a V, hence the name is V model. So this is
Okay.
designed as a V. Okay. So
Mm-hmm.
now, if we look at the advantages of disadvantages, so it is simple and easy to use. The testing activities like planning, test designing happens well before coding. This saves a lot of time, hence higher chances of success over the waterfall model. So here, what happens is, the test designing. So that happens before the coding and all is started. Okay,
Mm-hmm.
so that's why it saves a lot of time. It's a proactive defect tracking, that is, defects are found at earlier stage, avoids the downward flow of the defects. What do you understand by the downward flow? Means if there is any issue in the requirement, and so that should not go to the next phase. So that is
Mm-hmm.
called the downward flow. If there is
Mm-hmm.
some defect or error in the design phase, that should not come to the latter phases.
Mm-hmm.
And it also works well with small projects where requirements are easily understood, because requirements are also fixed here, right? Requirements are
Mm-hmm.
not changing in nature. What are the disadvantages? It is also a very rigid and least flexible, because in every phase the requirement is fixed, the design is fixed, the coding is fixed, and all. The software is developed during the implementation phase, so no early prototypes of the software are produced. So you'll be able to understand why we are focusing more on this prototype on the later stages. I mean, once you know what are the other models that are available, where we actually get the prototype, then you'll be able to understand why this prototype is required, and why these models are having these advantages, the waterfall model or V model, why these models are having this disadvantage. Okay. And if any changes happen in midway, then the test documents along with the requirement documents has to be updated. So this is also has to be done, because if the changes are happening in midway, then again you need to change everything. So that is also the disadvantage.
Mhm.
So when can we use V model? It's almost like same as the waterfall model. So you don't need to think it otherwise. When the requirements are defined, those are clearly documented and fixed. The product definition is stable. The technology is not dynamic and well understood by the project team. There is no ambiguity or undefined requirements, and the project is short. So basically, this is similar to waterfall model itself. Okay.
Mhm.
Okay. So any questions from this model?
No, no.
Okay. So see, I mean, there will be a bit of confusion, right? When you talk about the waterfall model and V model, there will be some confusion, because these two are similar in nature. So what do you need to remember is the structure. I mean, how the waterfall model is structured, how the phases are structured, and how the V model is structured. If you just remember that, you will be able to answer any question from there.
Mhm.
So that is what is required from your side. You need to understand the basic, and you need to remember the structure. If you will remember the structure, you will be able to answer. So the main difference between these models that we'll be able to understand here uh, in the next two models, which is iterative model and the incremental model. So here we'll get to see the differences, how these are different from the earlier two models that we have already discussed. So before we start talking about the iterative model, I will just send you something. Mm, yeah. Because it's easy to remember these models if you keep the diagram in your mind. Like if
Mhm.
you can remember the diagram, then it will be very easy for you to remember this. Mm, why does it not allow to send the files? Okay, I'm not sure why this is not allowing me to send the files. um okay, what I'll do is, you can take the screenshot, right?
Mhm.
Okay. Or like, if you, how can I share this with you?
No, I can take a screenshot.
Okay, fine. Then I'll just stop my share and like share this too with you, so that you can take the screenshot, and that will actually help you to remember these two models. So you can just take a screenshot of this too. So this is the iterative model.
Okay.
So just take a screenshot of this diagram, and
I
later
got it.
now we'll discuss
Yeah, I
about
got it.
this. Okay, and this is the diagram of the incremental model.
Yeah.
Okay, fine. Because if you remember this diagram, you'll be able to answer, or
Mhm.
you'll be able to you don't need to remember all the theoretical things, all the definitions. If you just remember
Mhm.
the diagram, it will be clear to you which model works in what way.
Mhm.
Okay, now let's go back to our slide. Okay, so what is iterative model? So in the iterative model, as the name suggests, it's the iterations of different phases, right?
Mhm.
So in the iterative process, it starts with a simple implementation of a subset of the software requirements, and iteratively enhances the evolving versions until the full system is implemented. At each iteration, design modifications are made and new functional capabilities are added. The basic idea behind this method is to develop a system through repeated cycles. That's why it's called iterative, and in smaller portions at a time, which is incremental as well. Now, iterative and incremental development is a combination of both iterative design or iterative method and incremental build model for development. Now, this iterative model and the incremental model is almost similar. I will tell you the difference, or you'll be able to differentiate between them by yourself. Okay, once we go through the details. So, if we consider iterative lifecycle model, which phases are there? It is also having a requirement phase in which the requirements for the software are gathered and analyzed. Iteration should eventually result in requirement phase that produces a complete and final specification of requirement. Then we have a design phase in which the software solution to meet the requirements is designed. There may be a new design or an extension of the earlier design. An implementation and test phase, when the software is coded, integrated, and tested. Then the review phase. Now, this review phase is very important because in each iteration, there will be a review where we'll demo the outcome of that iteration to the client. We'll get the feedback, and according to the feedback, we'll again iterate the same things and we'll make those
Mhm.
changes. So
Mhm.
here you can see now, if as it's incremental in nature and it's iterative in nature, everything, the requirement phase, the design phase, and implementation phase, these are coming back, right? So there is a scope of changes in the requirement, or there is a scope of changes in the design, there is a scope of changes in the implementation. While we are actually developing the whole software, in between them there is a scope of changes in the requirement, there is a scope of changes in the design, there is a scope of changes in the implementation, and also those can be tested. And once those are tested, we can show a demo, or we can demo it to the client as well. And so if they are having, or they have any suggestions with some of the changes, those can be incorporated in the next iteration. So
Mhm.
if, so what is the advantage? What do you understand by now? That the
So it is
advantage
not
is,
very rigid. It is not very
yes,
rigid. It's flexible.
is it's very flexible, and the changes can be incorporated early. And another thing is, in each iteration, so suppose each iteration is of 2 weeks. Okay, in every 2 weeks you are coming up with some of the requirement, you are doing the design for that requirement, you are making the changes, you are doing the testing, you are demoing it to the customer. Now if they are happy,
Mhm.
then on the top of those changes, you are again adding the capabilities in the
Mhm.
software,
Mhm.
right? So there is always the scope of change, there is always the scope of test whatever you are developing. So now as the testing is happening in the earlier stage, you'll be able to catch those bugs earlier. You don't have to wait till the completion of the development, which was happening in the previous stages, right? In the previous models, what we were seeing, that once
Mhm.
the whole application is developed, then only we were getting it for the testing.
Mhm.
But here the same thing is not happening. Here,
Yeah.
once a bit of the product is developed, some of the features are developed, we are getting it for the testing. We are testing those.
Right.
Now on the top of those features, the next features are getting developed. Or if
Yeah.
some of the changes are required, on top of that the changes will be done. So it will be
Mhm.
easy to test the smaller modules as well.
Yeah.
And as the features grow, your testing will also grow with that.
Mhm.
So this is the main difference between the iterative model, and if you talk about the waterfall model or the V model, this is the main difference there.
Sure.
So now if you just take a look at the the diagram that I just displayed. So the diagram is not there in this PPT. I would request you to look at the screenshot. So if you look at that, in the iteration one, what is happening? We have a requirement, we are analyzing the requirement, we are designing according to that. The testing is happening itself in that iteration.
Mhm.
Then then the implementation is happening and we are doing a review with the customer.
Mhm.
Sorry for that. Now in iteration 2, again we are going back to the design, we are testing, we are doing the implementation, we are reviewing it. And
Mhm.
then again we are going back to the iteration 3, we are doing the design, we are doing the testing, we are doing the implementation, we are doing the review, and finally when the whole product is developed, it's getting deployed and the maintenance activity is done.
Right.
So the planning, the requirement gathering, the design, the coding, the testing, and the review, so this you know are done in an iteration until the end product is developed.
Mhm.
So that is iterative model.
Okay.
Now what are the advantages and the disadvantages of this iterative model? Now you'll see the advantages list will get bigger and the disadvantage list will be smaller. In the earlier stages the disadvantages list was bigger, because these are evolved model. I mean, these are comparatively new models. So after the whatever the challenges we were facing while we were working on the waterfall model, or like in the V model, those have been overcome by using this iterative or incremental model. So in
Mhm.
iterative model, we can only create a high level design of the application before we actually begin to build the product and define the design solution for the entire product. So what does it mean? It means that the entire design or entire architecture is not designed you know in the earlier stage,
Mhm.
right? So a prototype is developed, a smaller prototype is developed in the first iteration, just to see that okay, whatever we are thinking, can it be done? Okay, a
Mhm.
prototype is developed and it is demoed to the customer. Now if the customer is happy with that, they're seeing and they are saying that okay, yeah, this is good, we can go ahead with this. Then on top of that prototype, the uh, low level designing is done, low level architecture is done, and then on top of that the the coding is done, and then again it is tested and again it is being demoed to the customer. So that's why later on we can design and build a skeleton version of that, and then evolve the design based on that what had been built. So every time we are developing, or we are doing on top of what we have developed already,
Mhm.
right? So
Yes.
in iterative model, we are building and improving the product step by step. Hence, we can track the defects at earlier stages. We have already discussed it, because in
Mhm.
every iteration, the testing is coming to the picture. So in every iteration, we are testing it, we are getting the defects, we are logging them, and the developers are also fixing them. So in the earlier stages, the testing is happening, and we are tracking the defects from there. This avoids the downward flow of the defects, because what was happening in case of the waterfall model or V model, the whole application was getting developed, and after that we were you know testing the application.
Mhm.
So the
Mhm.
whole design was done, then only the implementation was done, the coding was done, and then it was coming for the testing. And now if there was any defect in the, say, the designing phase, so that was flowing downward, that was coming to the implementation phase, and then it was coming to the testing phase where we're getting the defect.
Mhm.
But in this case, as it is in iterative in nature, it is incremental in nature, and the testing is involved from the earlier stage. So that's why we can catch those defects at earlier stage, and it stops the downward flow of the defects, right?
Yeah.
Okay. In iterative model, we can get the reliable user feedback. When presenting sketches and blueprints of the product to the users for their feedback, we're effectively asking them to imagine how the product will work. So what was happening in the earlier stages, in the earlier models, like we are developing the whole of it, then we were testing it, and then we were showing it to the customer that okay,
Mhm.
we have developed it. Now you say what is your feedback. Now if they are saying that okay, no, I didn't want this, I was wanting that, so in that case it was very difficult to change everything. You need to go back to the requirement phase, you need to do the changes in the design, you need to do the code changes, and then again you need to test the whole application. But in this case, in each iteration you are showing those prototype to the customer, and you are asking for the feedback. Now from that demo, if the customer is happy with that, they are saying that okay, no, this is fine, and you can go ahead and do the development on the next phase. But here, so what is the advantage of that? We can do the changes in the earlier stage. If the customer requires some changes from the earlier stage, we can do that. But in the previous models, it was not so easy to implement.
Mhm.
And finally, an iterative model, less time is spent on documenting and more time is given for designing, because in each phase, like we are doing the documenting, we are documenting whatever we are developing. So less time is spent on documentation, because in the earlier models, if we look at the earlier models, what was happening that you know everything was being done, and then everything was being documented, and then it was being sent to the as the input of the next phase. But here the thing is not likewise. Whatever you are developing in that particular iteration, you are doing the documentation of that. So you're not documenting a big chunk of feature. You're just documenting whatever you are doing in that particular iteration, and then more time is spent for designing, more time is spent for the testing and the feedback. So that is one advantage of iterative model. Now, what is the disadvantage of the iterative model? Each phase of an iteration is rigid and do not overlap each other. So that this is not a very big disadvantage. This is mentioned here, but I won't say that this is a very big disadvantage, because here we are like dividing the whole development life cycle into iteration. So obviously in an iteration you need to fix with the requirement, right? In that particular iteration, if the customer is coming to you daily and changing their requirements, so in that way you can't you know go forward with the uh, development. So in an iteration, you need to fix the requirement, and then you need to develop that. You need to demo it to that, and then the client can come up with the some of the changes which you can uh, implement in the next iteration. So yeah, in a particular iteration you need to be rigid, but overall if you look at the the whole model or the whole development life cycle, it's not rigid in nature.
Mhm.
Problems may arise pertaining to system architecture because not all requirements are gathered upfront for the entire software lifecycle. So this is something that you need to understand, because in the other cases, what was happening that we were fixing the requirement. So the requirement was fixed, right? But in this case, the requirement is not fixed. We are coming up with a small chunk of requirement. We are, doing our designing and implementation testing, and then we are again going back and taking the new requirements. What affects here is the system architecture, because the designing and the architecture is also not fixed in this case. So if we are coming up with some requirement which can affect the architecture as a whole, so then it becomes a bit difficult to implement those, right? Did you get
Mhm.
this point?
Yeah.
So at a later stage, if you are coming with some requirement which might require the whole architecture to change, so that might cause some problems, right? So
Mhm.
that is one
Mhm.
disadvantage of this model. And finally, the project progress is highly dependent upon the risk analysis phase. Hence, highly skilled resources are required for risk assessment, because this is an iterative model, and each iteration there are some risks involved, like this one, the changes in the system architecture. So this is one risk that is involved here, right? So
Mhm.
in this case, the risk analysis has to be done in each phase, and for that, like some of the highly skilled resources, some of the highly skilled architects are required. So this is also
Mhm.
one disadvantage. Okay, so now let's go to the last model that we are going to see today, and it's the incremental model. So what do we do in the incremental model? Incremental model is a process of software development where requirements are broken down into multiple standalone modules of software development lifecycle. So you can just open the diagram that you have shared.
Mhm.
Here you can see it's a better model than the iteration model, because in the iterative model the requirement was also changing, and now as the requirement was changing every time, or new requirements were added every time, so the issue was with the architecture. Like if something is coming which was not there previously, so that might affect the architecture design of your software. Now for that, here what is done, the requirement is fixed, and then the requirement is broken down to different modules, and then those modules are built parallelly. You can see the requirement
Mhm.
that is then separated or divided into different builds, and those are developed parallelly. The designing and the development of those different builds are done, the testing are done, and then the implementation are done,
Mhm.
right? Okay, so
Yeah.
let's come back to the slide. So each iteration passes through the requirements, design, coding, and testing phases, and each subsequent release of the system adds function to the previous release until all design functionality has been implemented. So this is done on top of the iterative model. Here also the iteration is there, but here the requirement is fixed, and on top of that it is divided into different standalone modules, and those are developed. In incremental model, the whole requirement is divided into various builds. Multiple development cycle take place here. Why it is mentioned that multiple development cycles take place here? Can you answer that from the diagram?
But yeah, because there are different modules.
Yes, correct. So we have divided the requirement into different builds, and
Mhm.
those different builds are developed independently. So for
Mhm.
each development, there is a development cycle associated with that.
Mhm.
So that's why multiple development cycles take place here, making the life cycle a multi waterfall model, right?
Mhm.
So if you look at this build one, so it is a waterfall model.
Mhm.
So that's why the waterfall model is also incorporated here.
Mhm.
Cycles are divided up to smaller, more easily managed modules. Incremental model is a type of software development model like V model, agile model, etc. So agile model, this is what we are most of the companies are adapting to the agile model, and this is the very well known model right now. So the interview if in the interview they ask you that what is agile model, you can tell them that it is a type of incremental model. Okay.
Mhm.
Okay, so what are the features of incremental model? Now system development is broken down into many mini development projects that we already know. Partial systems are successively built to produce a final total system that we also know.
Mhm.
Highest priority requirement is tackled first because the requirement is divided into subsequent builds. So there we check the priority, I mean which are the most priority requirements, and those are tackled first, those are developed first. And once the incremented portion id developed, requirements for that increment are frozen. So that means once we have the build one ready, so the requirement for that particular module is freeze, those are
Mhm.
frozen. So now let's look at the advantages and disadvantages. So the advantages are generates working software quickly and early during the software lifecycle, because as like the whole requirement is broken down into subsequent modules, and those modules are developed independently. So that's why it can be generated, the working software can be quickly generated,
Mhm.
and it can be generated early during the software life cycle. The model is more flexible and less costly to change scope and requirements. It is more flexible because each modules are developed independently. So if there is any change in the requirement that needs to be incorporated, that you can do in that particular build or that particular module. It is easier to test and debug during a smaller iteration, obviously, as the builds are divided into different modules, so it's easier to test those builds. In this model, customer can respond to each build after the development of each build. It is demoed to the customer, so the customer can also provide their feedback on that. Lowers initial delivery cost because we are developing each build differently, so it and those can be delivered independently to the customer, so it also lowers the delivery cost. It is easier to manage risk because risky pieces are identified and handled during iteration. So as we mentioned that the requirement is developed divided into different modules, and there only we can forecast those risks and handle those during each iteration. Now this needs good planning and design, because this is one disadvantage. Although this is an advantage, but this comes into the disadvantage as well, because when you are dividing the requirement into different build, so that needs good planning, right? If you need to forecast the risk as well, you need to prioritize the work as well, and then you need to divide those. So that's why it needs good planning, it needs a clear and complete definition of the whole system before it can be broken down and built incrementally. Because when you are dividing the whole requirement, so you need to have a clear picture of the whole system, what you are going to develop as a whole, and then only you can break it. So the thing is, if the build 2 is dependent on build 1, then you can't start working on build 1 and build 2 parallelly, right?
Hmm.
So that's why you need to divide it in such a way that those builds are not dependent on each other, so that you can start working on those independently. And
Mhm.
total cost is higher than waterfall. So why the total cost is higher than waterfall? Because this each phase is itself a waterfall model.
Mhm.
So that's why the total cost is higher here. So see, I mean, there could be a lot of advantage that you can list here, or a lot of disadvantages you can list here for each model. So this depends on how your development, what is your product, that is the first thing. What is the product that you are going to develop, and what is the span of the whole development? Is it a long term product, or is it a short term product? How is your requirement? Is your requirement fixed, or is your requirement is well documented, or is your requirement is changing in nature? So there are different parameters, and on each parameter you can fix your model. And I mean, frankly or honestly speaking, these things are not defined, or these things are not finalized by us, by the testers. So these are done by the architects or the management or the higher management, that which model we are going to work on. From our perspective, again, I would like to focus on that. These are required from the interview perspective. And that's why from your side, what do you need to remember is the difference between each model in a very high level,
Mhm.
right? Like this incremental model. So how this is different than iterative model? The difference is, in incremental model, the different the requirement is divided into subsequent builds, and those builds, the development of those builds follows a independent waterfall model. So it is
Mhm.
a I mean, there are different waterfall models that are incorporated here. So we can call it as a
Mhm.
multi waterfall model. Whereas in case of iterative model, in each iteration, we are building a prototype and we were demoing it to the client. And on top of that, the next phase of or next iteration of development was happening. So this is,
Mhm.
if you are able to express this to the interviewer, he will be happy.
Mhm.
So he doesn't expect you to answer all the points here. No, that is not the case. You just need to remember the diagram. So that is very important. Whenever
Mhm.
you are asked about the incremental model, you need to remember the diagram. What was the diagram? Okay, the diagram was, the requirement was there, the requirement is fixed
Different
into
bills.
different builds, and then each build has its own development model, own waterfall model. So if you just remember this, if you just remember the diagram of the iterative model, what was the diagram of iterative model? There was each iteration, and each
Mhm.
iteration there was the planning, there was the requirement specification, there was the designing, there was the testing, there was the implementation. And and then we were demoing it to the customer, we are getting the feedback, and according to that we were moving to the next iteration, and we were doing it iteratively until the whole product is developed.
Mhm.
So if you just remember this, that is enough. That is enough for you. You don't need to remember all these things in a like theoretical way, right? So
Mhm.
when can we use incremental model? Now if you have understood what is incremental model, you will be able to you know answer this without remember whatever is written there. So what is the when we can use incremental model? This model can be used when the requirements of the complete system are clearly defined and understood. Why this is required? Because until all the requirements are clearly known, you can't, divide those into subsequent modules, right? So that is one thing that is required here. Major requirements must be defined, however, some details can evolve with time. So there is a scope of flexibility there, but the major requirements, the critical requirements, the prioritized requirements has to be defined earlier, so that based on that you can divide those onto the modules. There is a need to get a product to the market early. So if there is a need to get a product to the market early, you can use the incremental model, because you can develop each build parallelly, right? So that makes the overall time less to develop or to build the whole product. A new technology is being used, resources with needed skill set are not available. So this is and there are some high risk features and goals. So if there are some high risk features and goals, then also like you can uh, do the risk analysis first, and according to the risk analysis you can divide the feature. Resources with needed skill set are not available. So if the resources with needed skill set are not available, then you can, divide the whole development into, or divide the whole requirement into different builds. The resources that you have, with those resources you can start the development of those builds. And you can, at the same time, you can find the resources which are required for the other builds to be developed. And once they are available, you can start the development of those builds, right? So that can be done as well. So these are the some of the cases where we can use the incremental model. But the main thing that you need to remember, where can we use incremental model, is where we have a set of requirement which is fixed, and those requirements can be divided into certain builds, and there is a requirement that um, we need to launch the product quickly to the market. So in that case we can divide it into different build, and then we can start the development in parallel. So in these cases we can use incremental model. So yeah, that was it from today's session. So it's a bit confusing, I would say it's a bit confusing, but again I would say that if you keep the diagram in your mind, you won't get confused. Okay, so just go through the diagram once, and then try to understand what is the core difference between these different models. And again, no one will ask you to write thesis on this, no one will ask you to write the theoretically write five differences between the iterative model and incremental model, or iterative model and waterfall model. Or no one will ask you to write the advantages and the disadvantages of this model. That is not the case. You just need to remember the basics, the diagram, and if you will remember the diagram, you'll be able to answer it by yourself.
Sure.
Okay,
Okay. Uh,
so that was it from today's session. Do you have any query till now?
no, I'll go through it and try to make sense. And I have a question I'll ask tomorrow.
Sure. The only thing is you don't need to, again, like you don't need to remember each and everything. Things are a bit confusing, but the only thing that you need to do is to remember the diagram. If you remember
Okay.
it, you will be able to answer it in the, because this is important from the interview perspective. And in the
Okay.
interview, they won't ask you anything else. They might ask you what is incremental model, and how it is different from iterative model. That's all. Or how it is
Mm,
different from the waterfall model, how it is different from the V model. That is all. That
mhm.
is all they will ask. They won't ask any other single question from here.
Okay.
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 So yeah, that was all from today. Please go through this and note down if you have any query, and then we can go through those on the next lecture tomorrow. And
Mhm.
as I mentioned earlier, I have uploaded an assignment that is pretty easy, and you don't need to write it lengthy in a lengthy way. It is just to check whether you have gone through everything and you remember everything. So you can just answer those briefly and upload the assignment. Okay.
Okay.
Okay, then have a good night.
Uh-huh. Yeah.
Yeah.
Thank you.
Bye.
You have a good
Yeah.
day. Uh-huh.
Thank you.
Mm.
Thanks a lot. Yeah. See you
Uh-huh.
tomorrow. Take care.
Uh-huh.
Bye.
Uh-huh.